Hello and welcome to Easy Projects. Today I will attempt to repair my dad's surround receiver. It decided to fail yesterday with a little poof, and now there's nothing on the outputs. But it seems to power up just fine, and it recognizes the incoming signals. So I tried plugging in the headphones and they're playing alright. But all the speaker outputs seems to be dead. So let's try to take off the cover and see what's going on inside. So to get an overview of this unit, we can start with the mains input, go into this board and into the transformer here. We have secondary windings on these two boards, some regulators, a small transformer down on the bottom board with some more regulators. We have what looks like a video input output board. We have a tuner, a digital board, and the main amplifier board is down on the bottom. And there's also a LCD and volume control board on the front here. So I've started to look for any loose connections or visual defects, but I can't seem to find any at the moment. Oops, that one looks like it's blown. Yep, we have a blown fuse. So let's try to replace this and see what happens. And we can soon make a collection of these, I think. So the blown fuse was found in this board over here. And it sits directly on the secondary winding of the transformer. So it seems like something is shorted out. So let's try to measure the resistance from that fuse to ground. And I found that these two nodes here will be what we're looking for. And you can see it's a dead short. Finding a short like that may not be as easy as it sounds, because it could be anywhere on any of these boards. So we can try to unplug the boards systematically and see if the short will disappear. And the output from the fuse goes through this bridge rectifier, and it goes into this connector. So we can try to unplug this, and we can try to measure these pins and see if we still have that short in there. And yep, it's still shorted, so at least we can tell that this board should be fine, and the short should be located on this board somewhere. But I think it's time to dig out the service manual for this thing, if we can find anything online. So I have found the schematic in the service manual, and the fuse that is blown is this one over here. We can see it goes for the connector we measured here, and it goes to the main board. And on the main board it is this node here called plus VCC. And it turns out this is it's a non-regulated supply rail for the amplifiers. And this means that the short could be anywhere on the board actually. This VCC powers 3 of the amplifiers, and VCC1 powers the other 2 amplifiers. So the short is between plus VCC and ground. I've also checked the minus VCC to ground, and it's measuring in the kilo ohms range, so that should be fine. We have these 2 caps between plus VCC, ground, and minus VCC, so it could be something with this cap over here, but it could of course be anywhere on the board. VCC goes into this bus line here, and it appears 7 or 8 times around the board, so plenty of things to check for shorts. If we take a quick look at one of the amplifier channels that gets powered from VCC, it does not seem that if any one of these devices would fail, that there would be a direct short between the two rails. The only two ground connections is over here and this one here. I have tried to follow the traces around, and it seems that there should be some resistance even if one of the devices fail dead short. But we also have a capacitor here in the mute section that sits between ground and VCC. So this could also be a potential issue. So it does seem like those two capacitors would be the only way a single device could fail and make a short between the rails. But of course it could be multiple devices that have failed, but it didn't sound like that. And since it didn't seem like any of these boards gets powered from the VCC rail, and I'll try to remove those so we can get to those two capacitors. So by undoing a few screws in the back and unplugging these two connectors, we can take out this video board here. And again, the VCC rail did not seem to go to this board, so I'm pretty sure that this would be all fine. And the same for this radio tuner board. And if I'm not mistaken, this board will do the digital processing of the signal and do the digital to analog conversion. It seems like the analog signals will go to the amplifier board via this connector board over here. And about 20 screws and a few connectors later, we can remove this digital board as well. Oops, that's cable tied. There we go. So I finally got this amplifier board out, and I could start probing around. And I found that this capacitor in the mute section actually has a series resistor, so it cannot be that one. But I did also find that the lowest resistance between VCC and ground is around this capacitor here. So I think I'll try to desolder that and remove it and try to see if that solves the problem. I forgot to record this, but it's this capacitor sitting here. There's one capacitor for each rail, and this was the positive VCC and this is for the negative, and this is for the other two rails. These two down here are smaller because they only have to power two of the channels, while these power the other three channels. And I also forgot to record the part where I measured the circuit. So I have soldered in a component lead here to simulate the capacitor when it was in there. So I just measured from where the ground lead enters the circuit here, and started probing the VCC rail. And I started at these power transistors and just went around here. You can see the resistance is decreasing here, so that will mean we're getting closer to where the short is. And if we go up here, it should, and the number gets larger again. And then measured something around here, and the resistance is getting lower. as I get closer to this bad capacitor here. So I finally measured directly across this. I can see the resistance is a little lower. When measuring something like this, it is almost essential to have a multimeter that have at least 3 or 4 digits after the decimal place, so you can see even small changes in resistance. But you have to be very consistent in your measurement. If I measure this, if I press a little harder, you can see it decreases, and if I loosen, it increases. So you have to be very consistent in the amount of pressure you put on these, because the difference in the resistance is very small. And with the capacitor removed, we now have 5.1 k ohm instead of 0.06. So I'll bet you that when we measure this capacitor, it's a dead short. Yep, we have a winner. Oh, a loser, I should say. So unfortunately I don't have any of those large capacitors, but we'll have to buy some, and I think I'll replace all 4 of them, because the next might be as bad as this one, so it could fail in about a week or 2, so I don't want to take all this apart again. And just a little detail, I couldn't find half of the power transistors. I think I know why, because they sit under the heatsink. It's a little funny how they just soldered directly to the traces. There's actually a few botches in this. And there's also a botched in a transistor down there. It's just flying in free air, it looks like. And oops, there's another one. Capacitor. So all the caps have been removed, and the new ones have turned up, so we can start solder those in. So this blue one is the new cap, and of course the black one is the old one. So one thing I don't understand is why on earth they would use 85 degrees caps in a receiver that gets very warm inside. I bought some 105 degrees caps, and hopefully they will last a little longer. So let's get these in place and see if it comes back to life. And just to check that everything is in order. Yep, that seems fine. Oops. Yeah. So it's all back together, and let's try to power it up and see if it works. Yep. That's it. And that's just some AM radio noise. But it seems like it's back up and running. So all that trouble for just one bad capacitor. Well, I hope you liked it, and thanks for watching. And please give it a thumbs up if you like to see more of these repair videos. And of course, you're always welcome to subscribe to my channel if you like that. See ya!